We're picking up after I took my wife home for dinner. We had a nice dinner. Nice dinner Saturday night, nice dinner Sunday night. I'm cooking uh, some different foods than I normally cook, so I'm maybe getting better. Anyway, back on to page 171. We're trying to see if their interaction terms are necessary for our model. And what we mean by parallel here is that they have the same shape, not that they don't intersect, but that they have the same sort of spread between each other, more or less. Because remember, the data is a sample, and remember, the data could have been different depending on our sample. So we talked about this particular model and whether or not we need these adjustments, um, beta 3 or beta 5 for the interaction terms. So there might be some difference between the two, but we want to know if they have the same shape or not. And if they do, then maybe we don't need those interaction terms for our model. So remember, we were talking about this on page 172. Our original model is the y equals beta naught. And remember, x1 is the treatment, and that's a categorical data. If you had the treatment, you had a 1, 0 if elsewise. X2 is a time, and that's a quantitative data. And this is what we had in our last video in terms of what our regression equation might end up being. All right, so let's go ahead and take a look at Minitab on how we got that. So before, our regression analysis was this entire part. And notice that we want to pay attention to, this will be our full model. We want to know our degrees of freedom, sum of square error, and adjust as mean squared error. So let's try the reduced model without the interaction terms. So again, stat regression, we'd fit a regression line. And here we'd go to our model and determine if we had anything to eliminate those. So we just have time, treatment, and time squared. All right, and so then we could go ahead and do that. And here we get this. We might take a look at the residual plot and say, ooh, that looks pretty bad. It looks kind of like the residuals, kind of have a pattern. Yeah, but the histogram of the residuals looks okay. If we look at against the predictors, maybe something a bit, but we could still go on with the expression. Remember, what we want to do is we want to use our f-test. So just as a reminder of where each one of these would be, so beta naught, of course, is just our y-intercept. Beta 1 is the one that's corresponding to our treatment. Beta 2 then, see if you can figure out what beta 2 corresponds to while I change colors here. Beta 2 would be with our time. So it would be 0.23, or estimate for beta 2 would be 0.2315. And beta 3 would be our times treatment. So that would be our negative 0.0134. And you could kind of try to figure out what beta 4 and beta 5 are while I change colors. Let's try purple for Taylor. So beta 4 would be this negative 0.00258. I mean, it would be approximated by that. And beta 5 would be this B5 of 0.0197. So this is my full model with everything, and I can calculate my sum of squared errors, my degrees of freedom, and my mean squared error, 9.75, 28, and then 0.348 in the denominator. And then my reduced model, remember it's going to have a larger sum of square error, will be 9.28 and 30. And remember, my numerator is just the number of predictors that I got rid of, which would be 2. And my denominator is my mean squared error, which has the same degrees of freedom as my full, and so that would be my 28. All right, so I get a p-value of 0.412. I can go ahead and calculate this to be 0.112. My degrees of freedom is 2. My degrees of freedom in the denominator is 28, and I fail to reject. And so what I then conclude, back to what I had at the originally, there's no interaction between treatment and time, or I could say that beta 3, beta 5 are 0, or the model can be reduced by eliminating the interaction terms. whatever it is, our model now will be without the interaction terms, beta naught plus beta 1x plus beta 2x2 plus beta 4x2 squared. So we're in the quadratic for phase, but we have no interaction terms. Now we kind of move on to the question whether or not there are main effects due to the treatment or to time.